Okay, grade 9s. I'm hoping we remember our formulae for area and perimeter. You were supposed to do that just before your break. So today we are going to look at composite shapes. So we looked at the regular, normal, basic, easy shapes. Today we're going to look at composite shapes, starting with area. Now please, 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 you need to treat area and perimeter like they're two completely separate sections. Do not get them mixed up. They've got very different methods of calculation. Okay, so we're starting with area. The area for composite shapes, there's actually something you need to do before you can even start the calculations, and that's identify what type of composite shape you have. Okay, so with composite shapes, you've either got shapes that have been stuck together, or you've got something that's been cut out or removed. Okay, so I'm going to do two separate methods for these. So you've got the stuck together type. Okay, and then you've got the cut out type. And I'll show you an example of each. Usually with this section, they will somewhere in the question say to you, calculate the area of the shaded region. It might not say the word shaded though. They might not have shaded it for you. But look out for that. If it does say shaded, it's a nice big tip for you that we're doing composite shapes area. Okay. So firstly, the stuck together type. So this would be something like, now example, would be something like, let's say we've got a square, and on that square we've got a semicircle stuck to it. Okay, so you see we've got a square and we've got a semicircle. So let's say they tell us that's 2 meters and it's a square, and we need to determine the area of that shape. Okay, so first off, identify that this is stuck together. We have a square, and stuck to it we have half of a circle. Okay, so first identify what type it is. Now the steps. Step 1. You're going to determine the area of each part. Okay, now how many parts do we have to this shape? We've got 2. We've got a square and we've got a semicircle. Okay, so we're going to determine the area of each part. So starting with our square, the area of a square is side times side. This little baby S here, little subscript, just to help me remember what I'm doing. I'm doing the area for the square. Side times side, then tell us that the side is 2 meters, so it's 2 times 2, which is 4, and remember area is in units squared. Okay, next up, next part is our semicircle. Now the area for a circle, watch what I'm doing here, the area for a normal circle is pi r squared, hey? Pi times the radius squared. But this is not a normal circle. This is half a circle. So because this is half a circle, we have to halve the formula. Half a circle, so we have to put in a half there. It's half pi r squared. Okay, so that's going to equal, let's substitute in, half times pi times radius. A little bit tricky, they haven't indicated the radius here for us, but we know that that is 2. We know that that is equal to that, and this thing is a square, which means whatever this side is must also be 2. And that goes from one side of our circle down to the other side. So we've got our diameter. They've given us that the diameter of our semicircle is 2. So if the diameter is 2, that must mean the radius is 1. Remember, the radius is half the diameter. So it's half times pi times 1 squared. And we go ahead and type it into our calculators. Okay, so you've got half times shift pi times 1 squared, and we get 1.57. Okay, so that's step 1. Determine the area of each part using the formulae. Okay, so for this, we used the formula that we learned last week, that we know off by heart. Okay, then step 2. Because it's a stuck together type, it means the total area of this shape is actually the sum of these 2 areas. So to find the total area, we take the area of each and plus it together. Okay, depending on how many parts there are. Okay, so that's the step. Now actually doing it for our question, the total area is equal to the area of the square plus the area of the semicircle, which is 4 plus 1,57, which is 5,57 meters squared. Okay, that's it. So that's if you've got a stuck together type composite shape. Now you might have a cut out type composite shape. So that's when you started. So here we started with a square and we added on a semicircle. So let's say instead of that, we started with a square and we cut out a semicircle. Okay, do you see the difference? Here we added a semicircle to it, here we cut the semicircle out of it. So here our total area was everything. Here our total area is much less, it's just this. So the first step is actually the same. Let's just for fun make the measurements the same. So it's a square of 2 meters where we've cut out a semicircle. So step 1 is the same. Step 1, determine the area of each part. Okay, so when we determine the area of each part, we've got to identify what we've got. We've got a square, that's what we started with, and we cut out a semicircle. Okay, so the area of a square, now we've done it, but we're going to do it again. The area of our square is equal to side times side, which is 2 times 2, which is 4 meters squared. Okay, the area of our semicircle is not just pi r squared. If it were a circle, it would be pi r squared, but because it's half a circle, it's half the area formula. Okay, so now we're going to go substitute in. We've got half pi. Our radius again is 1, because if that's 2, that means this is 2 because it's a square, and this is the diameter of our circle. So if the diameter is 2, that makes the radius 1. So it's a half times pi times 1 squared, which we've worked out over there, is 1,57 meters squared. Okay, so far it's the same as that question. The difference comes in here in step 2. Step 2, the total area is actually equal to the area of the main part minus the area of the cut out shape. Okay, so our main part was a square and we cut out a semicircle. So for this question, the total area is equal to the area of our square minus the area of our semicircle, which is 4 minus 1,57, which is going to be 2,43, I think. Let me check. 2,43 meters squared. Okay, so that is for area of composite shapes. You use your formulae to determine the area of each part, and then if it's a stuck together, you add them. If it's a cut out, you subtract them. Okay, now completely new page, completely different section, not related to area at all, is the perimeter of composite shapes. So I'm going to pause you here, erase this, and then we can start perimeter. Okay guys, so with perimeter, now this is completely independent of whether it's a cut out or stuck together. Okay, that's cut out, stuck together, that's only for area. Perimeter has nothing to do with that. Okay, for perimeter, you do not use the formula that we learned last week. Okay, do not use the formula unless you're dealing with a circle, because the only way to determine the circumference of a circle is using the formula. Okay, but in general, do not use formulae. Okay, so for perimeter, your steps. Let's do one while we're writing the steps, and then we'll do one a little bit later without writing the steps. So let's do this question. That's a little bit of a tricky one. Okay, so we're going to have a semicircle stuck to a rectangle, stuck to a triangle. Okay, do you see that? So here we have a rectangle with a semicircle and a triangle attached, and that's a right angle triangle. Okay, let's say that that is 4 meters and that is 2 meters. And this over here is 3 meters. Okay. So the steps here. Step 1. Okay, we need to determine the outside edges. We need to figure out the length of every single outside edge. Okay, so let's look. We know that is 4, we know that that is 2, and we know that that is 3. So we have 3 lengths. We still need that side and that side. Okay, we need to be able to walk, start at a point, walk all the way around the outside of our shape, and in doing so, we need to be able to say, yes, I know that length, I know that length, I know that length. We don't know this yet, so we need to find it. We don't know this yet, so we need to find it. Okay, so these 2 we don't know. Let's go figure them out. Okay, so first off, over here, I've got a semicircle. Okay, so in order to determine the length of the outside of a semicircle, I'm looking for the circumference of half a circle, or rather half of the circumference of a circle. So let's just call that one x and that one y for now. Okay, so determining x. X is the circumference. It's a long note to self. It's the circumference of half a circle. So to determine the circumference of a circle, we would have to use the formula, which is that circumference equals 2 times pi times radius. But is this a full circle? No, it's half a circle, so we use half the formula. It's half times 2 times pi times half. Okay, now our radius, let's look. We don't know the diameter, but we know that the diameter is the same as this. So if that's 2 meters, that's 2 meters, which means our radius is 1 meter. I'm not doing this on purpose. They're all ending up as 1. Okay, so we're going a half times 2 times pi times 1, and you should get 3.14 meters. Okay, so we've determined that. Now we need to find this out. Okay, so for y, let's look. How can we figure that out? Well, it's the hypotenuse of a right angle triangle, okay? So y, we can say this is the hypotenuse of a right angle triangle. And we know how to determine the hypotenuse of a right angle triangle. We'll use Pythagoras. Okay, so let's go for it. We've got y as our hypotenuse. So it starts with your hypotenuse, y squared equals. Now we look, our other 2 sides are 3 and that's the same as that, 4. So y squared equals 3 squared plus 4 squared. We square everything we can, so we've got y squared equals 9 plus 16. Y squared is 25, and we square root, don't forget to square root both sides. And we get that y is equal to 5. So our hypotenuse is equal to 5. So we now know that x is 3.14. We know that y is 5. So now we can walk around the outside and say we know everything. Awesome. So we can go ahead on to step 2. So step 1, determine the outside edges. Step 2, add them all together. Okay, you always add. With area, sometimes you add and sometimes you subtract. You need to know when. With perimeter, you always add. Please make sure you know the difference. Okay, with area, you add if it's stuck together, you subtract if it's cut out. But with perimeter, it doesn't matter what your shape looks like. You add always. You always add. Okay, I don't want to see anyone subtracting with perimeter. Okay, so let's go for it. Our perimeter of this shape is equal to, we start in one place and we walk around the outside, adding together all the numbers as we walk. So we're going 4 plus 2 plus 3 plus 5 plus 3.14. And now we're back to where we started. So let's go ahead and add them. That's 6, 9, 14, 17,14 meters for our perimeter here. Okay, so that's the first one we're going to do. Sorry, there's a cat trying to knock you over. That's the first one we're doing. I'm going to pause you, erase, and we can do a second example. Okay, guys, so here's example 2. We've got this sort of weird, makes me think of a cartoon character, I don't know, this long rectangle here. Maybe it'll help if I sort of break them up into the parts for you. So we've got this long rectangle, or actually it'll probably be easier to see it as this rectangle, and this triangle. Okay, so what I want you to do is, actually I want you to pause the video to copy down the question, to try it, and then to push play and see if you did it right. Okay, but so we've got 7 centimeters, 1 centimeter, unknown, unknown, 2 centimeters, unknown, and 6 centimeters. Okay, so a reminder, 2 steps. Step 1, determine all the outside edges, and then step 2, add them all together. Okay, regardless of the fact that this over here is cut out, doesn't matter, you add together for perimeter. If I had asked for area, we would subtract. But I asked for perimeter, you always add with perimeter. Okay, sorry, I know I'm emphasizing it a lot, but it's a mistake that I see happening a lot and it breaks my heart. Okay, so let's go for it. We know that that is 2 centimeters. We know that that's 1. We know that that's 7, and we know that that is 6. So there are 3 edges here that we don't know. We don't know this, let's call it X. We don't know this, let's call it Y. And we don't know that, let's call it Z. Okay, so first off we need to find X, Y, and Z. So X, let's think for ourselves. X is one of the sides of a right angle triangle. Okay? Whenever we have a right angle triangle and we are looking for one of the sides, we can use Pythagoras. I've just realized in the previous question, I forgot to use Pythagoras as my reason. Please don't do what I've just done. Okay. Whenever you use Pythagoras, you write Pythag, there's your reason. Okay, so let's go for it. My hypotenuse of my triangle here is that 2, 5. So we've got 2, 5 squared equals our unknown side x squared plus 2 squared. Okay, we do all the squaring we can, so we've got 2.5 squared, we get 6.25 equals x squared plus 4. We're going to now solve this equation, so keep x squared on the right, move our 4 over to the left and subtract. So we've got 2.25 equals x squared, and now we don't forget to square root both sides. Okay, we square root both sides. And when we root 2.25, we get 1.5. So we've got that x is 1.5. Okay, awesome. We've got one of our 3 unknown sides sorted. 1.5. Now, y and z. Y and z, it's actually a bit more logic than following a method. So for y, let's look at this. For y, we've got this rectangle here, making it blue. Okay? We know that this whole side is 6, which must mean that this whole side is 6. And we know that that little section, there it says, is 1. So that must mean y is 5. Okay? And similarly for z, we know that this whole thing is 7, and that portion of it is 2.5. So that must mean that this portion of the 7 is going to be 4.5, eh? Yeah, 4.5. Okay, so step 1, determine all the sides. We now have all the sides. Step 2, we can work out the total perimeter by adding them all together. So I'm going to start here and walk around clockwise. So I'm going 1 plus 4.5 plus 5 plus, now be careful, this 2.5 is not part of the shape. If I were to walk around the shape, I wouldn't walk across here on this dotted line. I would walk on the solid lines, up there and then down. So it's plus 2 plus 1.5. Okay, we do not add that in our perimeter. It's not part of the perimeter. Okay, so we're there now, up to 6. And then across 7, and we'll end where we started. Okay, so we add them all together. We've got 1 plus 4.5 plus 5 plus 2 plus 1.5 plus 6 plus 7. And we get our total perimeter as 27. And they've given us our units, centimeters. And I've just done the same thing again. I've just realized I used Pythagoras. I didn't give a reason. Sorry, guys. Please don't do what I do what I say. Use your reason for Python. Okay, and that is it. There are questions that I want you to do. It is written on your schedule, so I can tell you now, textbook, in your textbook, on page 3 and 4, you can do all those questions for me, please. The textbook is the one that is on OneDrive, the one that Mrs. Piver uploaded. Okay, so you're going to do pages 3 and 4 in the textbook on OneDrive from Mrs. Piper.